What are prime numbers? The numbers which have no other factors other than the number itself and 1 are called prime. For example, 2, 3, 5, 7, 11 and so on. Okay, these numbers have no other factor. If you take for example 7, 7 has no other factor, right? 7 and 1. Similarly 11 has no other factor, 11 and 1. So these are all prime. Most of the odd numbers are prime. The only even number which is prime is 2. Okay, even and prime. For example, if you take any other even number like 4, it already has a factor of 2. Okay, so it is not prime. Even 6, 2 into 3, it has two other factors, 2 and 3, then the number itself and 1. So what are composite numbers? Those numbers which are not prime, they have different factors other than the number and 1, they are composite. Okay, like in the example 4 and 6, 8, 9 also. 9 can be written as 3 into 3. Since it has 3 as a factor, it is also a composite number. Okay, what about 1? 1 is neither prime nor composite. Okay, the number 1 is neither prime nor composite. Let's cross out the composite numbers in the table. Okay, 1 to 100 numbers are given, right? Whichever the numbers have factors, you have to strike them out. Okay, like 99, 3 is a factor, so it is not a prime number. Similarly, these numbers, they are also not prime because these are all having 5 as a factor. Okay, so you have to around whatever left, they are all prime. 2, 3, 5, 7, 11, 13, 17, okay, 19, 29, 31 also prime, and 37. Okay, and so on. You have to verify whether they are prime or not. See, 69 is not a prime number since it has 3 as a factor, 3 and 23. Okay, so the prime numbers are written here. These are all prime numbers. Okay, below 100. So what is the advantage? Why we study prime numbers and composite numbers? We can break apart the composite numbers as the product of prime numbers. Okay, we can write the composite numbers as the product of prime numbers. That is the advantage. For example, 4 is written as 2 into 2. What about 12? 12 is 2 into 6, right? And 6 is again 2 into 2 into 3. This is about 12. Okay, similarly 20 can be written as 2 into 10. 10 can be written as 2 into 5. So 2 into 2 into 5. So composite numbers are made up by multiplication of prime numbers, and this is called prime factorization. This method of showing a composite number as the product of prime numbers is called prime factorization. Now we need to put some numbers so that this is valid statement. Okay, 6 equal to 2 into 3. What about 8? 2 into 2 into 2. Oh, this is prime factorization only. 18 is 2 into 9. 9 is 3 into 3. What about 30? 2 into 15. What about 15? 15 is 3 into 5. Okay. Now let's see the divisibility rules. if you have a number like 224, if you want to tell whether it is divisible by 2 or not, how to check actually without actually doing the division? How to identify? Whatever the numbers have the endings to 0, 2, 4, 6, 8, that means the unit digit is one of them, like 0, 2, 4, 6, 8, then it is divisible by 2. Okay, so any even number is divisible by 2, so the ending must be 0, 2, 4, 6, 8. Okay, that means you can also say the unit digit must be divisible by 2, either 2 or 0. Okay, they are all divisible by 2. Okay, you can check by taking any example. If you take 224 by 2, it is 112, and the unit digit is 4, which is an even number. Okay, so it is divisible by 2. So we can quickly tell whether these numbers are divisible by 2 or not. This is divisible by 2 and this is not divisible because the unit place has a number 3 and 3 is not divisible by 2, right? So this number is not divisible by 2 and this is divisible, so these 3 are divisible by 2. Now we have to find out the numbers which are divisible by 5. Are these numbers divisible by 5? See the unit digit again. The unit digit is 5, so this is divisible by 5. The unit place digit is 0, so it is divisible by 5. The unit place digit is either 5 or 0, then it is divisible by 5. Other than that, they are not divisible. This one is not divisible. Okay. Now we have to choose the number which is divisible by 3. Okay. For that, what they have done, they divided actually using long division method. They found that 261 is divisible by 3, 262 is not, 263 is also not, but see the remainder. The remainder here is 1, here the remainder is 2. Okay, now you add 2, 6 and 1, what will you get? You will get 9, right? 9 is divisible by 3, so 261 is also divisible by 3. What about sum of 262? It is 10. 10 is not divisible by 3 and the number is also not divisible by 3. What about 263? That is 11. 11 is not divisible by 3 and 263 also not divisible by 3. Okay. So if the sum of the digits is a multiple of 3, then it is divisible by 3. Okay, you take any example, 7, 6, 4, 3. Okay, now add them up. 4 plus 3 7, 7 plus 7 14, 14 plus 6 20. So this number is not divisible by 3, since 20 is not divisible by 3. Yeah, it is a strange rule. Now let's see the exercise. List 3 multiples for the following number, ordering them from the smallest. Okay, it is like number table. For 4, we can start from 4 into 2. Okay, 4 into 2 is 8, 4 into 3 is 12, 4 into 4 is 16. Okay, 7, 7 2 is a 14, 7 3 is a 21, 7 4 is a 28. What about 11? 11 2 is a 22, 11 3 is a 33, 11 4 is a 44. 14, 14 2 is a 28, 14 3 is a 42, 14 4 is a 56. Okay, list 3 common multiples for the following pair of numbers, ordering them from the smallest, and also write the least common multiple. 3 common multiples. First one is 12. Okay, and then 24, 12 3 is 36, like that. What is LCM here? Least common multiple, it is 12. What about 4 into 9 is 4 into 9 36, 72. I think it is 108. Yes, 108. Okay, LCM is 36. 5 and 8, 5 and also 8 also in the similar fashion you have to multiply them because they don't have a common factor. Okay, but coming to the 3 and 9, they have a common factor, that is 3. So 9 is starting. Okay, smallest is 9. 9 2 is 18, 9 3 is 50, sorry 27. So this is LCM. Okay, list all the factors of the following numbers: 9, 12, 24, 30. Okay, we'll start with 9. 9 can be written as 3 into 3. 12, 2 into 6, again 2 into 2 into 3. Okay, so the factors here are 3, here 2 and 3. Okay, for 12 it is 2, 3. If you have to list all the factors, you have to include 1 also, and you have to include the number itself. So for 9, 1, 3, 9. Okay, list all the common factors of the following numbers and also write the highest common factor for each pair. All the common factors. Okay, 9 and 15. 9 can be written as 3 into 3. 15 can be written as 3 into 5. What about common factor? 3. And there are no other common factors for these two numbers. What about 14 and 21? 14 is 2 into 7, and highest common factor is 3 in this case. 21 is 3 into 7. Only common factor is 7, and this is the highest common factor. Let's see 24 and 40 also. 24 is 2 into 12. Okay, that can be written as 2 into 2 into 6, and 6 can be written as 2 into 3. 40, 2 into 20. 20 is nothing but 2 into 10. 10 is nothing but 2 into 5. Okay, so what are all the common factors? First one is 2, next one is 4, and then 8. See, all these three, okay, are there in both 24 and 40, right? 2 into 2 into 2. So 2, 4, 8 are the common factors. Highest common factor is 8. Okay, find the least common multiple and highest common factors for each. Okay, 8, 12, 24. What about HCF, highest common factor? 8 is 2 into 2 into 2. 12 is 2 into 2 into 3. 24, 2 into 12. 12 is 2 into 6. 6 is 2 into 3. So the highest common factor is this, 2 into 2. Okay, so 2 into 2 is nothing but 4. So HCF is 4. Okay, we found HCF using prime factorization. You can also find it using division method also. Okay, now we need to put 2, 3 or 5 in the blanks to make up a composite numbers freely. I will write first 2, 3, 5 only, then 6, 5 is 30. Okay, now 2, 2, 3, 5, 4, 5 is 20, 23 is 60. Okay, similarly you can write for the third. Find multiples of 2, 3 and 5 among the numbers in the box. 2, 4, 8. 2, 4, 8 is a multiple of 2. Okay, and what else, 460 also, and then 912, and then 810. That's it. Okay, what about multiples of 3? It is a bit tricky. You need to add them up. 2 plus 4 6, 6 plus 8 14. So this is not multiple of 3. 3 plus 3 plus 9, this is a multiple of 3. Okay, individual numbers are multiples of 3, right? 1 to 1, this is 4, not multiple of 5, multiple of 3. 5 plus 5, 10 plus 1, 11 is not divisible by 3, so it is not a multiple of 3. 4 plus 6, 10, so it is not. 9 plus 1, 10, 10 plus 2, 12, 12 is divisible by 3, so this is multiple of 3. 8 plus 5, 13, 15, 15 is divisible by 3, so this is also a multiple of 3. 8 plus 1, that is also 9, so 810 also, and then 15, next one is 15, so 951 also, and then this is 5, this is not a multiple of 3. 5 plus 2, 7, 7 plus 7, 14 is not multiple of 3. Writing multiples of 5 is easy. 515, 460, 555. The units place, you have to see the units place, either it should be 5 or 0, and then 725. Okay, there are two bells. Bell A rings every 8 minutes and bell B rings every 6 minutes. The bells ring together at noon. Okay, when is the next time they will ring together? This is a LCM problem. Okay, so 8 comma 6, what is the LCM? 2 4 ja, 2 3 ja, so LCM is 12. 2 into 4 into 3, sorry, 24. LCM is 24. After 24 minutes again they will ring together. 12 noon they rang together. So next one is after 24 minutes, that is 12:24 p.m. they will ring together. Okay, I have a piece of paper with 36 cm long and 24 cm wide, and I want to spread squares of the same size all over the surface of the paper. How long is the length of the side of a biggest square possible? This is a HCF problem, highest common factor. Okay, so 36 24, what is the HCF? How to find? 24 36, write it like this. 24 1 is 24, 2 is bigger than 24, 2 is 48, that is bigger than the number itself, so you have to proceed with 1 only. This is 12 is the remainder. Now you have to divide 24 with the remainder. Okay, so 12 2 is 24. Now we got 0, right? When you got 0, this is the highest common factor, HCF. So 12 cm is the answer. You can also check this answer using prime factorization. Okay, we arrange rectangular tiles 5 cm long and 7 cm wide like the figure on the right to make the smallest square possible. How many cm are the sides of the smallest square we can make? We need to find out the smallest square, right? So it's better than here 7 times it becomes 35. Here 5 rectangular tiles on the along this direction, x direction, that becomes 35 cm. Okay, and here along the vertical direction 7 tiles will give you 35 cm. So it is LCM problem. So the smallest square we can make is 35 cm. There are 45 apples and 18 oranges to Russell. Russell want to distribute apples and oranges equally to maximum number of children without any remaining. Find the number of children and how many apples and oranges do each children gets. Since it is maximum number of children, so it is a HCF problem. 18 45. Okay, 18 2 is 36. Again it is 9. 18 will come here. Okay, So 9 2 is 18. We got 0, right? Remainder as 0. So this is HCF. HCF is 9. So the maximum number of children are is 9. Okay. And how many apples and oranges do each children gets? Apples is 45 by 9. So 5 apples each one will get. And what about oranges? Oranges (18 by 9), 2 oranges, 5 apples and 2 oranges. Okay, that's it. We will meet in the next class with a new lesson.